If we take a look inside the cylinders of a two-stroke engine, we will find that it is filled with ports. These ports can be divided into two categories. The bigger port, which is usually one, is the exhaust port, while the smaller ones are for the intake. To make the exhaust flow better, some two-strokes also have auxiliary exhaust ports. But for this video, we will just focus on a singular exhaust port. To produce more horsepower, it is necessary that the exhaust port is as large as possible. So most manufacturers try to go as wide as they can. However, there is a point when they can't go any wider and they will have to go taller. But taller exhaust ports, even though they make power, they have a drawback. Taller exhaust ports produce very high power at high RPM, but at low RPM, there is very less power and very low torque. On top of that, the power band of this engine becomes very sharp. Such a configuration is very suitable for applications like racing. Racing motorcycles are always driving very high and they rarely come down in RPMs. So for that purpose, these type of engines are suitable. But these type of engines are terrible for use in the streets because you have to struggle a lot just to get them going. And once they finally get to high RPMs, suddenly lots of power kicks in, which is very hard to control. However, if we use a very short exhaust port, we might get very good low end power and torque down below, but we will be sacrificing our peak power. This type of porting is mostly used in street bikes. Such engines are easy to control and best for use in the streets. Now, as we can see, both of these designs have drawbacks, and to get the best of both worlds, engineers came up with a brilliant technology, the Powerwall system. Yamaha calls it the YPVS, and Kawasaki calls it KIPS, which stands for Kawasaki Integrated Powerwall System. The Powerwall system works by adding a valve in the exhaust port. This valve travels up and down, making the exhaust port shorter or taller when required. At low RPM, the power valve stays down, making the exhaust port shorter. But as the RPM increases, it gradually rises up, making the exhaust port taller and taller. This gives us the low end torque and power to get going, and the sweet top end power to be fast. Now let's compare power versus RPM curves of these three engines. The power of an engine with a short exhaust port will be relatively higher at low RPM, but there will not be any significant increase in power as the engine revs higher. In case of an engine with a tall exhaust port, there will be very less power at low RPM, but suddenly at high RPM, the horsepower will skyrocket and we will get considerably more power at higher end. Now the two-stroke engine equipped with a power valve will have very good power at low RPMs and also very decent top end power. This combines the best of both worlds, and this is probably the reason why most two-stroke nowadays, be it motocross or road racing, they employ a power valve system.